Welcome, students. Let's continue our chapter Matter in Our Surroundings. So far, we discussed about the characteristics of the particles of matter, and as I discussed with you, that the modern scientists has classified the matter on the basis of physical and chemical properties, right? So, on the basis of physical states, all the matter can be classified into three groups. And that is because of the variation and the characteristics of the particles of matter. The three groups are solids, liquids, and gases. So, if you look here, there are a lot of examples of all the three states of matter: sugar, sand, iron, wood, pencil, book. These are all solids. Water, milk, petrol, these are all liquids. Air, oxygen, CNG, LPG, carbon dioxide, in fact, steam, these are all gases. So, solid, liquid, and gases are called the three states of matter, or you can say that matter exists in three physical states. Now, let's discuss all of these in detail. So, let's start with the properties of solids. So, students, solids have the following characteristic properties. Solids have a fixed or definite shape and fixed volume. Solids cannot be compressed much. In fact, they are least compressible. Solids have very high densities. They are very heavy. Solids do not fill their container completely. Solids do not flow. The space between the particle of solids is minimum, and the force of attraction between the particles of solids is maximum. And the movement of the particles is minimum, is very least in solids. Now, why solids have these kind of properties? We will discuss that in detail, but we'll discuss that a little further, okay? Now, if you take a pen, book, needle, a piece of wooden stick, and sketch the shape of all these things. When you sketch the shape of these things, you will observe, you will see that all the given articles have definite shape, they have distinct boundaries, they will have fixed volume. So these are all solids, and solids have definite shape and definite volume. In fact, if you hammer them, if you pull them, or if you drop them, they have negligible compressibility. In fact, they are least diffusion. And there's one more important thing about solids, that solids have the tendency to maintain their shape when subjected to outside force. That means solid is a rigid form of matter. They will break, solids may break under force, but it is difficult to change their shape. So they are very rigid. Rigid means something unbending, inflexible. If you take stone and you will try to bend it, or you will try to stretch it, nothing will happen to it. So stone is a rigid. So solids are rigid form of matter, and due to their rigidity, they maintain their shape when subjected to the outside forces. So this is an identifying characteristic of solid, that is, they are rigid. And again, the same thing, solids do not require a container to keep them. If you are having a brick or a log of wood, these are two common solids, and they do not require any container to keep them. But yes, there are some kind of exceptional cases in front of us. Like we know that um, um, solids has a fixed shape. Now, if I talk about rubber band changes its shape on stretching. Then why do we call it a solid? So, see students, rubber band is considered as solid because it changes shape under the action of force which stretches it, and when the force is removed, the rubber band regains its original shape. It comes into its original shape like all other solids. If rubber band is stretched with a large force, it will break. So, it is a solid. In fact, if you take the case of a salt and sugar, when salt and sugar are put in jars of, say, different shapes, they take the shape of the jars. They indicate that they do not have fixed shape. But if salt and sugar do not appear to have fixed shape, then why do we call them solids? So actually this problem arises because salt and sugar have very tiny crystals. Salt and sugar are considered to be solids because the shape of the individual crystals of salt and sugar remain fixed. Even when they are put in jars of different shapes, the shape of crystal doesn't change. Okay. In fact, we also came to know that solids cannot be compressed much, right? Now, if we take sponge that can be compressed easily, then why do we call sponge a solid? Again, a sponge is considered to be a solid because its compressibility is due to the presence of minute pores in it, which are filled with air. And when we press the sponge, air is expelled from its holes, which makes it highly compressible. So these are some exceptional cases in solids. Let's talk about the properties of liquids. So the characteristic properties in liquids is like liquids have fixed volume, but they have no fixed shape. Liquids take the shape of the vessel in which they are placed, and space between the particles is intermediate. Okay, and the force of attraction between the particles is again intermediate. In fact, the movement of particles is intermediate, and they are less compressible. Like solids, liquids cannot be compressed much, and the rate of diffusion is more than solids. We'll discuss about diffusion in detail. And liquids have moderate to high densities. They are usually less dense than solids, and liquids do not fill their container completely. And one more important thing, that liquids generally flow easily, and the material which possesses the property of flow, which can flow, that property is known as fluidity. So basically, liquids possess fluidity. Fluid means material which can flow easily and which requires a vessel to keep it. So if we take water, that is a fluid, and if we pour water on the top of table, what happens? It will flow over the surface of the table, right? And moreover, water requires a vessel to keep it. So you can say that liquid is a fluid form of matter which occupies the lower part of the container in which it's kept. Okay, and it does not fill the whole container. But yes, liquids require a container to keep them. But because of the property of fluidity, liquids are the fluid form of matter. Okay. Now, let's discuss the properties of gases. So, gases have neither a fixed shape nor a fixed volume. They acquire the shape and volume of the vessel in which they are kept. Gases can be compressed easily into a very small volume, and the space between the particles is maximum. They are very far apart from each other. Force of attraction between the particles is minimum because of the greater distance between the particles. The movement of the particles is maximum. Of course, a lot of space is present. They are most compressible. It means gases can be compressed easily. Okay, gases can fill the container completely, and gases can flow easily. So again, gases are also the fluid form of matter which fills the whole container in which it's kept. So gases also possess fluidity. Okay, and the rate of diffusion is more in gases as compared to solids and liquids. Now, students, we came through we observed that solids, liquid, and gases have different properties. But why solids and liquids and gases have so much different properties? So, for that purpose, we'll explain that by using the kinetic theory of matter. As per the kinetic theory of matter, the particles of matter are in continuous motion and possess kinetic energy. And there is some forces of attraction between the particles of matter that are known as interparticle forces. Okay, and these forces of attraction tend to hold the particles together and control their movement. And when the particles are close together, then the interparticle force of attraction is maximum. And as the distance, as the space between the particles increase, force of attraction between them will decrease. Okay, and the movement of particles, that means the kinetic energy of particles, can be changed by heating the matter or by cooling it. Okay, higher the temperature, greater will be then the movement of particles. So we can now say that the following properties of particles determine the physical state of matter. The following properties of particles decide whether the given substance will exist as a solid, a liquid, or a gas. What properties? First one, the space between the particles. If, like in case of solids, the space between the particles is minimum, and it's little more in liquids, and maximum space is in particles of gases. And next is the force of attraction between particles. That means the interparticle force. It is strongest in solids, less strong in liquids, and negligible in gases. And then the third important thing, that is the amount of movement of particles. That means the kinetic energy of particles. It's minimum in solids because the space is less, more in liquids, and maximum in gases. And with the help of these three properties, we can describe the structure of solids, liquids, and gases, and explain the differences in their properties on the basis of these structures. See, in solids, you can see here in the figure, the particles are closely packed. There's a strong force of attraction between the particles of solid, which holds them together in fixed positions. And then the position of particles in a solid is fixed. Okay, and the particles only vibrate about their fixed position because they cannot move from one position to another. Okay, then the spaces between the particles of solid is very, very small, and when space is small, it means the particles have the minimum kinetic energy, and due to this, solids have the most orderly arrangement of particles. So now you can explain the properties of solids, like solids have fixed shape because the particles are closely packed, their positions are fixed because of the strong force of attraction. Solid has fixed volume because the space between the particles is fixed. Solid cannot be compressed much because its particles are already very closely packed and there are hardly any space between them. In fact, solids have high density because the particles again are very close. Solids does not fill the container completely because particles are held tightly by strong interparticle forces and cannot leave their position to fill the whole container, right? And in fact, solid does not flow because its particles are held very strongly. That is, they are it's unable to leave. Particles can't leave their fixed position because of the strong interparticle forces. And when it comes to liquids, you can see particles are close together, right? But they are not as close as in solids. In fact, the particles are somewhat loosely packed in liquids. The space between the particles of liquid is slightly more than that in a solid, but they are still very small. And there's quite a strong force of attraction between the particles of liquid, which holds them together. But the force, it's not strong enough to hold the particles in fixed position. So, due to comparatively less strong interparticle forces, positions of particles is not fixed. Okay, and the particles of liquid can move from one position to another within the liquid. And the particles of liquid have more kinetic energy than the particles of solid. Due to this, liquids have more disorderly arrangement of particles than solids. Okay, and the particles in liquid are also vibrating. Okay, so now you can explain the properties of liquid, right? Liquid does not have a fixed shape because the position of particles is not fixed due to comparatively less strong forces of attraction between them. Liquid take the shape of container because the particles of liquid can slide over one another easily. Liquids has a fixed volume because at a given temperature, space between its particles is fixed. Liquid cannot be compressed much because its particles are still quite close together and have very small spaces between them. Liquids has comparatively high density because its particles are still quite close together. Liquid does not fill its container completely because its particles are held fairly strong by interparticle forces and hence cannot leave the body of the liquid to fill the whole container. Okay, and the last property, that was liquid generally flows easily because particles are able to slide over one another due to slightly weaker interparticle forces of attraction. So let's come to gases. The particles in gases are much farther apart from one another as compared to solids and liquids. Space between the particles is very large. Force of attraction is negligible because of the very large space. So obviously the particles are free to move in any direction then, right? The position of particles of gas as well as the space between the particles of gas are not fixed. Particles have the maximum movement, that means the maximum kinetic energy, right? Due to this, gases have the most disorderly arrangement of particles. And because of high kinetic energy and negligible forces of attraction, particles of a gas move with high speed in all directions. In fact, when the fast moving gas particles hit the walls of the container, they exert a pressure that's called gas pressure. So, a gas exerts a pressure on the walls of the container in which it's kept. Now, the pressure exerted by gas, that is because of the collisions of the fast moving gas particles against the walls of the container. So when a gas is put in an empty container, it quickly spreads throughout the container and fills it completely. If a gas is heated, particles of gas start moving faster and faster, in fact. Okay. So with the help of this, you can explain the properties of gases. Like gas does not have fixed shape because the position of particles is not fixed. Gas does not have fixed volume because the space between the particles is not fixed. And since the particles of gas are free to move anywhere, it takes the shape and volume of the container. Gas can be compressed easily because its particles are far apart and there are large spaces between them which can be reduced by compression. Gases have in fact very low density because its particles are very apart from one another. A gas fills its container completely because due to high kinetic energy and negligible forces of attraction, particles of gas are moving with high speeds in all directions. And last but not least, that gases flow easily because its particles are comparatively free to move anywhere, right? So these are the properties of solids, liquids, and gases with their explanation why there's a difference in properties of these three states of matter. Now, there's an activity that shows us that solids and liquids cannot be compressed, but yes, gas can be compressed easily. For that purpose, we'll take 300 ml of glass syringes having frictionless piston, okay, and the nozzle of all the syringes are closed by inserting them in separate rubber cock, okay, so as to prevent leakage from them, okay. Now then remove the piston from all the syringes. In the first syringe we fill common salt, okay. In the second syringe we fill water, which is a liquid, okay. Common salt, that was a solid, okay. In the first syringe we fill common salt, which is a solid. Then insert the piston back into the syringe after applying some vaseline to piston for a smooth movement, okay. Then in second syringe we will fill water, which is a liquid, and then insert the piston back into the syringe after applying some vaseline to it, okay. Then in the third syringe we do not fill anything because it's already filled with what? Filled with air, which is gas, right? So we just put the piston back in it after applying again some vaseline in it. We now place some kind of weight on the top of a piston of each syringe to put pressure on all the three, to put pressure on common salt, put on pressure on water, to put pressure on air filled in them, okay. Now what will we observe? Definitely we will observe that the piston of first syringe containing common salt, that does not move down on putting weight, right? This shows that on applying pressure, the volume of common salt in the syringe does not get reduced. This means that on applying pressure, common salt does not get compressed. Now, since common salt is a solid, so we can say that solid does not get compressed on applying pressure, right? In the second syringe, the piston of second syringe containing water also does not move down on putting weight. And again, this shows that on applying pressure, volume of water does not get reduced. So water does not get compressed, right? And since water is a liquid, so we can say that liquid does not get compressed on applying pressure. Now comes the third piston containing air. You will see that piston will move down considerably on putting weight. Why? This shows then that on applying pressure, volume of air is reduced. This means that on applying pressure, air gets compressed into smaller volume. And since air is a gas, so we can conclude that gas can be compressed easily by applying pressure. So gases have high compressibility. They can be compressed into a small volume by applying large pressure. And due to the high compressibility, fairly large mass of gas can be put in a small metal cylinder by compression, right? Such gas cylinders can be transported conveniently from one place to another. Like you are having in homes cooking gas, liquefied petroleum gas, LPG, right? Which we use in our homes as a compressed gas, yeah, or the oxygen gas supplied to hospitals in cylinders, that is also in compressed form. In fact, the CNGs, compressed natural gas, that's filled in cylinders, that is being used increasingly as a fuel to run vehicles like cars and buses. It's all because of the high compressibility of gases.